Hi guys, in this video tutorials we are going to discuss about the graph traversal algorithms. I have chosen the main graph traversal algorithms which are depth first search and breadth first search for this tutorial. I hope you guys are already aware of what is a graph and what is a node, and mainly we are discussing them in our interviews. And graph is like another kind of tree. We can do the traversal starting from one node and we can traverse through all the adjacent or connected nodes. Data structure wise, we are using stack and queue for the implementation, but not only these two, you can either use many other data structures where we are using in any language. Here is the graphical illustration of how breadth first search and depth first search works. When you see the breadth first search, it will always give the priority to the next level. That's why we are calling it as level traversal as well. It will always first give the priority to the next level of nodes. After the completion of the iteration of this level, then only it will go to the next level. But in depth first search, the priority always given to the child nodes. So once all the child nodes are traversed, then only it will move to the other nodes of the tree. We can discuss more about this traversal and the implementation when we are doing the Java coding. Okay guys, let's move to the solution implementation for the depth first search. There are multiple ways that we can do the implementation. In this tutorial, I have chosen a recursion way and the stack data structure way to do this implementation. This is the graph which I'm going to use for my implementation. This graph contains 7 nodes, you can see, which is from 1 to 7, and I have given the sample outputs for this implementation. There's no only one concrete output we can get from the traversal, because it depends how you traverse through and which node is chosen. Especially when there are multiple child nodes, we can starting from any child nodes while do the traversal. Okay guys, let's move into the recursion implementation. Okay guys, let's start with the coding. First, we are going to do the recursive implementation. I have already created the class which is DFS Traversal, and you can see another class here which is called node, and there are 3 variables I have kept there. First one is value, adjacent nodes, and also visited. So value is to keep the actual value of the node, and also adjacent node, which is a list of nodes which we need to keep the list of child nodes for each particular node. And there's another variable which we are maintaining as visited. This is to understand whether this node is already visited or not. And here there are 7 nodes which I have created. As you saw in the graph, I want to have 7 nodes. In the static block, I have assigned the values to these nodes. I have created the list of objects for each node. So you can see n4 n7 I have created, and these two n4 and n7 does not have any child nodes. So in the graph we call them as leaf nodes, and all other nodes, they have their own child nodes. Okay, let's start with the coding. I'm going to create the method for this. Let's name it as traverse. This method, we need to pass the starting node. How you going to start the traversing? Which node you want to start? So as per the DFS traversal, you may remember that we need to start with the iteration of the child nodes. So let's do that. So I'm going to get the adjacent nodes, and I'm going to use the Java 8 for each lambda process. So this is going to be my first node, and here I need to do my logic. So if you see here, what we are doing is we are going to iterate through the adjacent nodes. So since it is depth first search, what you want to do is you need to iterate through each of the child nodes. So when you come to this list, what you want to do is you need to again traverse to each of the node of these child nodes to understand or to traverse if there is any child nodes inside this inside this child nodes. So let's call the traverse again. That's how you can traverse it from here. You can call the same method, so then it will come here, then it will loop through the adjacent nodes of these child nodes and it will visit them. So this is done, and next you want to make sure that before you traverse, there's one more thing that you need to do. You have to check whether this node is already visited or not. So I'm using this is visited variable to make sure that it is not yet visited. And another thing that you want to do is you need to mark this node as visited, and this is the place that you want to do that, because once you reach to this method, you know that node is already visited. So what we are going to do is we are going to set visited true here. Also you can put some print statement to identify which node is you going to visit. So this is the implementation. So before I go to further explanation, let's try to run this. So I'm going to use main method. So I can call traverse. Yeah, you will not able to call traverse because this method is not static. So let's mark it as static. I'm going to start with node 1, but you can choose any node where you want to start. Let's run it. Yeah, I think we made a mistake. So what we need to do is we should check whether it is not visited, then we will do the traversal. Yeah, here we go. We have the list of nodes. This is the hierarchy which is visited 1 2 4 5 3 7 6. So we can quickly go through this list. Since we started with n1 has 3 child nodes, n2, n5 and n7. So it will take the first child node n2, then it will go and see whether this child node has any other child nodes. So if we go to n2, it has n4 as a child node, so then it will visit the n4. That's why you can see n4 here. Then it will go to the n4 and see whether it has any child nodes, but n4 does not have any child node because it's a leaf node. Then it will come back to n2 does not have any other child nodes, and it will come back to n1 has n5 as a child node. Then it will go to n5 and see whether it has any child nodes, and it has n3 and n6. So you will see here n4 is there, so you also see here n5 is there, it is already visited. Then it will go to the child node of n5, which is n3 and n6. You will say n3 here, then it will go to the n3 and see whether n3 has any child node. Yes, it has n7, so it will visit n7. Then it will go to the n7 and see whether it has any child nodes, but it does not have any child nodes. It's again a leaf node, so n7 is printed. Then it will come back to n3. N3 does not have any other child node. Then it will come back to n5 and it will see n5 has any other child nodes which we did not visit yet. Yes, it has n6, so it will print n6. So it will complete the iteration of the n5 and it will come back to n1. Then it will go to the rest of the child nodes of n1. We have already visited n2, n5 and n7 is pending, but n7 is already visited through n3. So since it will not go again, so whole graph is already traversed and all the nodes are visited. So guys, this is the implementation that you can do using recursive traversal, recursive implementation. Let's move to the other implementation which we are going to do with the stack. Okay guys, let's start with the second implementation of the DFS traversal. So this time we're going to use the stack. Okay, let's create a method traverse with stack. So similarly we are going to pass the starting node or root node or whatever node here. I'm going to create the stack here, which will be a node type. Okay, there are three methods that we are going to use in a stack here. So one is to push a node into the stack, another one is to pull from the stack, other one is to read from the stack. So I think you might know that we already discussed about the stack, how it is working. Okay, we're going to add the node into the stack. So I want to add my first node here when it is start iteration, and next what I'm going to do is I need to iterate through the adjacent node of this stack. I need to iterate through the adjacent nodes of this node. So for that I'm going to use for each. Here I will take my node as n, then and here I'm going to take my node as n. In here again, similar to our previous implementation, we need to check whether it is already visited, and if it is not visited I'm going to add this node into the stack again. Okay, so it will iterate through the given node and it will insert all the nodes into the stack. Okay, this is done. But the next thing is that you need to see is how you're going to iterate through all the nodes. So this is another important things, because here what you are going to do is you are going to insert all the child nodes of the given node, but it is not going to iterate through the all other child nodes. So for that we need to do is there's some mechanism that will keep running and which will insert into the stack. Hence I'm going to use that while loop. There what I'm going to do is I need to check whether the stack is empty. If it is not empty I need to iterate and do the same thing for all the nodes which I inserted in the stack. But before that, there's another thing that you may remember, that in our previous implementation we had to do that set visited value. So we can do that here. Once we reached here, what you need to do is we need to read from the stack. So for that you can use stack.pick method and you will get the next object that it's going to read. So you can assign to the node. Once you read it, you have to remove it from the stack. So for that you can use node.pop. I'm sorry, it's not node, it should be stack.pop. Then it will going to remove the next object from the stack. So you have the object already here, so you can simply remove it from here. After that what you need to do is you need to check whether this is already visited. That's the another check that you want to make here. So you're going to see whether it is already visited. If it is not visited, what you have to do is you need to set as visited, because you have already reached here and you have already visited the node. Also, you can put a printf statement here as well, because this is the time which is going to visit this node. So I'm going to get the value here. Yes, our implementation is done. Maybe you can go through the code again. What we are doing here is this is the stack implementation of the graph traversal, depth first graph traversal. So first you will receive the node here. Once you receive it, you will going to insert it into your stack. The first node is inserted. Then the second thing is you need to think is how you're going to iterate through the all nodes. So this is the way that you're going to do is you will create a for loop and you will get all the adjacent nodes and you're going to insert all into the stack. And once those are inserted, you need to think about how you're going to iterate through the child nodes of these nodes. So you have inserted the list of nodes into here, and then what you want to do is you need to read them from the stack. For that I'm using this while condition, so it will iterate through the stack for all the inserted nodes of that stack. So since this is the stack, it will starting from the last child node which you inserted there, since because of the behavior of the last in first out. So whichever inserted you last will be taken the first. So you will read it here, you will assign it to the node variable, then you will remove it from the stack, then you will check whether it is already visited. If it is not visited, then you will print the value. This is the node which I'm going to visit now, then you will set visited true here. This is how it is working. Let's see the result. So I'm going to comment out this method call. So I'm going to use my new method, and similarly I'm going to pass n1 as the value. Okay, we got the result. Yeah, it is 1756324. Okay, let's see how it is working here. Okay, I'm going to use our example values for this. So this is how it is working. So we pass n1 as the starting node. So n1 is here, you are going to push it into the stack, then it will come here, then it will iterate through all the nodes, and it has n2, n5 and 7. So now it's going to insert n2, n5 and 7 into the stack. Now this is the hierarchy that you will see in the stack, and this is the order which keep the values inside the stack. So once the first node is visited, you have already iterated through the adjacent nodes of this node 1 and you have inserted into the stack. Then what is going to do is, inside the while loop, you will get the last node so which is number 7. So it will get the number 7 and it will again go inside this loop and see whether it has any child nodes. As per our example, number 7 does not have any child nodes. So then it will come back here, it will get the next node. So then it will be number 5, and again it will go inside to the while loop and see whether it has any adjacent nodes. Yes, it has. So then it going to insert number 3 and number 6 into the stack because it has these two child nodes. Then stack has the last node as number 6. So when the while loop is working again, it will take number 6 as the next node. So you have number 6 here. It will go inside the loop again and see whether number 6 has any other child nodes. Yes, it has number 7, but when you come to here, number 7 is already visited. Number 7 is already inserted into the loop, so it's not going to be inserted again because we have this n visited is visited check here. So number 7 is not going to be inserted. So number 6 is now visited. Then it will come to the last point, which we started number 6 traversal. So the next node will be number 3. It will take number 3 here and it will go and see whether it has any other child nodes. Yes, it has number 7, but number 7 is already visited. So because of this condition, it will not going to be inserted to the stack again. So number 3 also done. So number 5 is done. So then it will come back to the starting point of this iteration. It will take the next element from the number 1 node. It will be number 2. Then it will go to the while loop and see whether number 2 has any other child nodes. Yes, it has. Number 4 is there. So then next iteration will be on the number 4. But if you go to the number 4 does not have any child nodes. So that's a end of iteration of the number 4. Then it will come back to number 2. Number 2 is already visited. Then it will go to the number 1. So we have already visited all the nodes of the graphs here. So you will see how it is given the iteration order here, 1 7 5 6 3 2 4. Yes, this is how the graph traversal works here, and we use the stack implementation. So guys, I just like to remind you that whenever you're facing an interview, that you can explain the graph traversal depth first search, how it is working, and what are the implementation that you can do, what are the ways that you can do. But I suggest maybe if someone asks you to do the actual coding, you can better use of a stack rather using the simple linked list or recursive implementation. But it depends, but I suggest you can go with the stack implementation, because when you are discussing about the stack and queue, these are the very good examples that you can give graph traversal. Queue is for the breadth first traversal, and stack is used for the depth first traversal. Okay, this is the end of video that we are doing today. So let's meet with the breadth first traversal next time. Thank you very much.